Mathematical problem related to solubility. Let us see the problem. Today's problem is 100 milliliter 2.5 times 10 to the power minus 5 molar solution of ferrous chloride is added to the 150 milliliter solution of sodium hydroxide of 6.7 times 10 to the power minus 5 molar. Precipitation of green color of ferrous hydroxide is formed. What is the ionic product of ferrous hydroxide? Let us simplify the problem. One solution of ferrous chloride solution. Its volume is 100 milliliter. Strength of this solution is 2.5 times 10 to the power minus 5 molar. Another solution of sodium hydroxide. Its volume is 150 milliliter. Strength of this solution is this 6.7 times 10 to the power minus 5 molar. In the question, it is said that one solution is added to another solution. Let us take both the solutions in another beaker to understand better. That is, here two solutions, ferrous chloride and sodium hydroxide. Its volume will be 100 plus 150, that is 250 milliliter. In the solution, what is formed? Ferrous chloride plus sodium hydroxide. Ferrous hydroxide and sodium chloride. Ferrous hydroxide ionizes in this way. Ferrous 2 plus ion, 2 hydroxide ion. Here, this is ferrous hydroxide. If we want to calculate ionic product of ferrous hydroxide, then we need concentration of ferrous ion times concentration of hydroxide ion. So, in this solution, ferrous hydroxide is formed that ionizes to ferrous ion and hydroxide ion. If we know concentration of ferrous ion and hydroxide ion, then we can calculate ionic product of ferrous hydroxide. Now, first of all, let us find concentration of ferrous ion and hydroxide ion in the mixture. We have to find in the mixture concentration of ferrous ion and concentration of hydroxide ion. Let us see before mixing what is the concentration of ferrous ion here. Before mixing, 100 milliliter 2.5 times 10 to the power minus 5 molar ferrous chloride solution is equivalent to 100 milliliter 2.5 times 10 to the power minus 5 molar ferrous ion. That is ferrous chloride ionizes completely to form ferrous 2 plus ion and chloride ion. So concentration of ferrous chloride equivalent to the concentration of ferrous 2 plus ion. So concentration of ferrous chloride is equivalent to concentration of ferrous ion. So before mixing, concentration of ferrous ion, suppose S1, that is 2.5 times 10 to the power minus 5 molar, and before mixing its volume is 100 milliliter. When this solution is taken here with the solution of sodium hydroxide, that is in the mixture, after adding this solution to this beaker, then its volume is, suppose V2, this is 250 milliliter, and after mixing we don't know the concentration of ferrous ion, that is to be calculated. Concentration of ferrous ion, concentration of ferrous ion has to be calculated in the mixture. Before mixing, concentration of ferrous ion is this, and after mixing, what is the concentration of ferrous ion, that has to be calculated. So according to law of dilution, V1S1 is equal to V2S2. According to law of dilution, we can write this. We have to calculate S2, that is concentration of ferrous ion in the mixture. V1S1 divided by V2. This is equal to, we can write V1, before mixing the volume is 100 milliliter. Before mixing, strength of ferrous ion is this, 2.5 times 10 to the power minus 5. And after mixing, what is the volume? Volume is 250 milliliter. Then this is equal to, we can write 1.0 times 10 to the power minus 5 molar. That is, we got concentration of ferrous ion after mixing here, this 1.0 times 10 to the power minus 5 molar. This is the concentration of ferrous ion in the mixture. We got it. Now let us find concentration of hydroxide ion in the mixture. So before mixing, suppose volume of sodium hydroxide is V3, then V3 is 150 milliliter, and S3 before mixing, S3 is concentration of sodium hydroxide. This is actually 6.7 times 10 to the power minus 5 molar. This is concentration of hydroxide ion before mixing, because this 150 milliliter 6.7 times 10 to the power minus 5 molar sodium hydroxide solution equivalent 150 milliliter 6.7 times 10 to the power minus 5 molar hydroxide ion in the beaker before mixing. So before mixing, concentration of hydroxide ion is this, because sodium hydroxide ionizes completely to form sodium ion and hydroxide ion. So one molecule, one hydroxide ion. This molecule, this number of hydroxide ion. So before mixing, concentration of hydroxide ion is this. Then After mixing V4, suppose this 250 milliliter after mixing, and after mixing, what is the concentration of hydroxide ion? We have to calculate it. After mixing, what is the concentration of hydroxide ion? That is, we have to calculate. According to law of dilution, we can write V3 S3 is equal to V4 S4. Then S4 is equal to V3 S3 divided by V4. This is equal to V3. V3 is this 150 times S3. S3 is this 6.7 times 10 to the power minus 5 divided by total volume 250 milliliter. This is before mixing, this is after mixing. This is equal to, we can write 4.02 times 10 to the power minus 5 molar. That is, we got concentration of hydroxide ion in the mixture. This is concentration of hydroxide ion. So in the mixture we got concentration of ferrous ion and concentration of hydroxide ion. Now let us calculate ionic product of ferrous hydroxide. We got concentration of ferrous ion 1.0 times 10 to the power minus 5 molar, and concentration of hydroxide ion 4.02 times 10 to the power minus 5 molar. Ferrous hydroxide establishes an equilibrium state in this way: ferrous 2 plus ion, 2 hydroxide ion. Now ionic product of ferrous hydroxide is equal to, we can write concentration of ferrous ion times concentration of hydroxide ion. This coefficient will be as power. Then concentration of ferrous ion, this 1.0 times 10 to the power minus 5 times concentration of hydroxide ion, this 4.0 times 10 to the power minus 5 square. This is equal to, we can write using calculator, 1.616 times 10 to the power minus 14. This is ionic product of ferrous hydroxide in the solution, which indicates precipitation of green color of ferrous hydroxide. That is, ionic product is this. It means solubility product of ferrous hydroxide will be less than ionic product of ferrous hydroxide. That is why precipitation occurs. So this is ionic product of ferrous hydroxide and precipitation occurs. Thanks for watching.